Hello everyone, welcome to lesson 7-7, solve inequalities by multiplication or division. This lesson is found on page 505. Now remember that an inequality is not an equation. It actually means that one side is not equal to the other. One side is greater or less than the other. Let's look at a real world connection. An astronaut in a spacesuit weighs about 300 pounds on Earth, but only 50 pounds on the moon. Looks like 1/6, right? 1 part of 6. Weight on Earth is 300 pounds, which is greater than weight on the moon of 50 pounds. If the astronaut and spacesuit each weighed half as much, would the inequality still be true? Well, let's see. If we were to divide this by half, we would get 150, correct? 150. And if we divide it by half, it would be 50 by half divided by half, it would be 25. So is the inequality still true? Yes, it is. So whatever you do to one side of the inequality, you must do to the other side, similar to how we've done with equations. So is the inequality still true? Yes. Okay, question 2. Is the weight of one astronaut greater on Pluto or Earth? Would the weight of 5 astronauts be greater on Pluto or on Earth? Explain by using your inequalities. So on Earth, they weigh 300 pounds. On Pluto, 67. So this times 5 would be 1,500 pounds, right? On Earth. And over here times 5, I'm just going to do a quick front-end estimation. 5 times 3 is 300, and 5 times... So it would be about 335 pounds. Okay? So is it still correct? Is it still true? Well, we know that 300 pounds is greater than 67, right? 300 is greater than 67. So 5 times 300, because you're saying 5 astronauts, 5 times 300 is still greater than 5 times 5 astronauts on Pluto. So you see that? They're both being multiplied by 5. Question 3. Is the weight of one astronaut greater on Jupiter or on Earth? Well, let's see. On Jupiter, well, 796 compared to Earth. So Earth is less than Jupiter. Would the weight of 5 astronauts be greater on Jupiter or on Earth? Explained by using inequality. Same idea. We know that Jupiter, 796 pounds, is greater than on Earth, 300 pounds. So 5 times that weight in Jupiter is still greater than 5 times the weight on Earth. Notice that whatever we do to one side of the inequality, we must do to the other side, right? So the multiplication and division properties of inequalities. Positive number. The multiplication property of inequality and the division property of inequality state that an inequality remains true when you multiply or divide each side by the inequality by a positive number. What they mean is this, boys and girls. Take a look here. We have A is greater than B. Let's just say 6 is greater than 4. Okay, if we wanted to really name them with numbers. 6 is greater than 4. If A is 6 and B is 4. And then whatever we do to one side of the inequality, let's say we want to multiply it with C, okay, we multiply it with C, let's give C a value of 2. We must do the same to the other side. You see how it's done here and there, okay? Same with division. If you divide A divided by C, you must divide B divided by C, as you can see there, okay? If A is less than B, you can also do the same thing. Okay, whatever you do to one side of the inequality, you must do it to the other. These properties are also true for greater and equal to and less and equal to. Okay? Okay, let's solve 8x is less than or equal to 40. Now, you could pretend like this is an equal sign, and we could do it the same way we've done equations. Okay, where we isolate the variable and invert the operation. On this side is multiplication, on this side will be division. Or we could do it the way where we try to work out the 8 so that we leave the x all by itself by doing the opposite operation. You see here it's 8 times x. Well, we're going to divide out the 8 so they cancel each other out and it's gone. But we did it to this side of the equation, so we must do it to this side, as you can see right there. Okay? So then when we divide it, we know that x equals 5. So on this side, we know that 40, 8 times x, is less than or equal to 40. That means this must be at the very minimum 5. So that 8 times 5 is 40. Okay, at the very minimum it's going to be 5. 8 times 40 is 5. Sorry, not minimum, at the maximum. It can't be any greater because the number is less than or equal to. If you were to graph this on a number line, it would look like this. You have your number line here, and we know that it's less than 40 or equal to. So you would use a solid dot, solid colored inside, and then you would draw your line in the direction that we are implying here, okay, towards it's less than 40 or equal to. That's why you fill in the circle. If it's not equal to, you just leave the circle not filled in. You leave it empty. It's just an empty circle. The same applies to division. We know that we're saying here that d over 2 is greater than 7. This expression is greater than 7. So if I divide a number divided by 2, it's still going to be bigger than 7. So it would probably have to be minimum, the number here divided by 2, it would have to be at least 16, right? Because 16 divided by 2, at the very minimum, 16 divided by 2 is going to be 8, and 8 is greater than 7. Any less than 16 here, and this will not be true. Understand? So we have to do the opposite of division, which is multiplication, or its multiplicative inverse, because remember this is over 1, and these two cancel each other out, so that we're only left with the d, okay, or 1d you could say. And then if you multiply one side, this side, by 2, you must multiply the other side by 2, as you see it here, and now you have d is greater than 14, okay? But as I was mentioning before, it has to be minimum 16, okay? And this is telling us that it's not 14, it's just saying that d is bigger than 14, it has to be bigger than 14. Okay, if you understood the two examples, please go ahead and do A and B now. Pause the video, please. Okay, we have to isolate the x, so let's divide it by 4, and let's divide it here by 4. So now we have x is less than 10. There we go. And for this side, we have to multiply by its multiplicative inverse, which is 7 over 1, right? 7 over 1, which cancels out these 7s. And this side multiplied by 7 as well is going to give me 42 is greater than or equal to x. Now we're going to do practically the same, but with a negative number. Multiplication and division properties of inequality, negative number. Okay? When you multiply or divide each side of an inequality by a negative number, the inequality symbol must be reserved for the inequality to remain true. So let's see what that means. Okay? For all numbers a, b, and c, where c is less than 0. Okay, let's see here. So if we look at these numbers, I think it'll make more sense over here. Okay, let's say that 7 is greater than 1, which we know. 7 is greater than 1. And we multiply 7 times a negative number, okay? That 7 is going to become a negative number, a much, much smaller number, right? Because we multiplied it by a negative, so it's further down on the number line. Here's 0. It used to be around here, it used to be around negative 7, and now it's gone all the way down to negative 14. Oops, negative 14. Let me fix that. Okay, all the way down there. Now, here on this side we had 1. Okay, and if we multiply times negative 2, it's going to become negative 2, which would be around here, negative 2. So now you see, it used to be 7 was greater than 1, but now 7 multiplied times negative 2 is going to be negative 14. Now it becomes less. It becomes much less than 1. And that's going to happen every time when you multiply by a negative number, a positive times a negative number. So the symbol has to be flipped around for it to remain true. See how we changed the symbol around? Right there. It used to be right there, okay? It used to be 7 was greater, but now we have to change it around so that the statement can remain true, because it became a much smaller number when multiplied by a negative. So here's the first example. We have negative 2g is less than 10. We're going to work out the negative 2 by dividing it out. Because we're dividing it out from the other side too, this number is going to become negative. Okay? So we have to flip around the inequality sign. And you can see that it's true, because now g becomes negative 5. Okay, so g is going to be greater than negative 5. As you see here, g is going to be any of these numbers greater than negative 5. It could be negative 2, negative 1, 0, 1, 2, 3, towards the positive. Okay, for example 4 now, we're dividing on one side, so that means we have to multiply. Do the opposite so we can remove the negative 3. We multiply it by negative 3, it cancels it out, right? Right there, it's gone, but we also have to do the same to the other side, and it becomes negative 12. Notice that we had to change the inequality, okay? Because when we're multiplying a greater number, even though this side is larger, we're multiplying a greater number by a negative number. It's going to become a greater in the sense of negative, which really, in the direction of the negative, which really means it's a smaller number. Okay, and when you graph it, you're saying that x is greater or equal to negative 12. So if it's equal to, you have to fill in the circle. Notice how it's a circle in there. It's a dot that's colored in because it's also equal to. So it's this value, or greater. You notice that the negative numbers are getting smaller. That means the value is increasing. Okay, go ahead and try question C on your own. Pause the video. So k over negative 2 is less than 9. Okay, notice that the 9 is greater on this side, right? But I've had to change the sign around now because 9, a greater number, being multiplied by a negative number, is going to become a bigger negative number, which in reality is smaller. So this side is less than. Okay, this side cancels each other out. These two cancel each other out. I'm left with k is greater than negative 18. So what does that look like? If k is less than, I'm going to circle it. I'm not going to fill it in. Notice I'm not going to color it in because it's not equal to negative 18. It's just greater than negative 18. So it's from that point on this way. Notice I'm moving in the direction that the negative numbers are getting smaller because as they get smaller, they're worth more in the negative, right? And then they'll get to 0 in positive numbers. Question 5. Ling earns $8 per hour working at the zoo. Write and solve an inequality that can be used to find how many hours she must work in a week to earn at least $120. And interpret the solution. Okay, she must earn at least $120. How many hours does she need to work? So our inequality, amount earned, is what we're going to enter first. There it is, our amount earned. Okay, $8. Times, okay, times number of hours, we don't know, it's x. So it's 8x has to be greater than or equal to, okay, greater than or equal to 120, because we said at least $120. Okay, so $8 per number of hours has to be at least or equal to 120, okay? Greater than or equal to. And there we go. Okay, 8x. We work out the 8 as we've done. Okay, we divide it out, and we divide this side out. So she needs to work at least 15 hours, or equal to 15 hours, right? X has to be greater to or equal to 15 hours. And there's your statement right here. So Ling must work at least 15 hours. Please leave the guided practice for class so we can use it as our reminder or lesson or warm-up. I believe you are ready to now do the independent practice. Please complete the entire front page and the back of the page. Let's do 16 and 17 together since we still have a little bit of time. Make sure that you do 15, and I will be looking for 15 as a key answer. Okay? Make sure that you do it. There's your start. But let's do 16 and 17. 16 is less than, so I know that 16 is less than 8 times a number. Then 8 times a number could be there, n. Okay, and what is my solution? Well, when I divide both sides divided by 8, on this side I'm left with n because I'm dividing out the 8 out, right? And I'm going to divide the 16 as well, and I'm left with 2, right? So 2 is less than n, or n is greater than 2. Alright, the product, you know, we're multiplying the product of a number and 5, the product of a number and 5, so I know I have 5 and a number, is at most 30. At most. So it's going to be at the very most, so it has to be less than or equal to 30. Because at the very most, this right here, this product is going to be, at the very most, it's going to be 30. So it's going to be less than 30, right? Because at the very most, it can be 30, or equal to, right? Because it can still be 30. Let's solve it. When I divide both sides out, divided by 5, I'm left with an n on this side, and if I divide 30 by 5, I will get 6.